At the Basingstoke Makerspace, we frequently get members and visitors that are confused about the various types of computer files being used. I thought I'd create a simplified map that shows an overview of the main file types and how they are related. The picture I've created is available on our website at the address shown here. My goal was to create a single picture to help inexperienced users see how the different categories of computer file are used. I'm aware that for some people, even this simple picture is intimidating, so I've created this short video to explain how it was built up. The most common form of picture file on computers is the bitmap. Essentially, bitmap files are just a list of the colours of every single cell in a square grid. There are a large number of different bitmap file formats. The extension types listed here are some of the most common ones. In contrast, a 2D vector format describes a picture by specifying all the elements that go to make it up. Each element is defined precisely, for example, the points and slopes that make up a shape, or the position and fonts for every piece of text. So, we have two distinct ways to describe a picture, either as a bitmap or as a set of vectors. Cameras, for example, produce bitmap files, and there are many applications that work with them. Similarly, there are other applications that work with vector files. Bitmap editing applications can all output to printers, often via specialized printer-friendly formats like PostScript. Similarly, vector-based applications can output formats that work well with vector output devices like laser cutters, vinyl cutters, and flatbed plotters. Most vector-based applications can easily output bitmap files on the few occasions when that is needed. It is more challenging to convert a bitmap into vectors, for example by tracing outlines, but many of the vector applications have some level of that capability. In the Makerspace, we don't just use two-dimensional files, we also have to handle three-dimensional shapes, often in the form of three-dimensional models. There are a range of file formats that hold these models, and it's possible using photogrammetry tools like Meshroom to generate a 3D model from a large collection of photographs of an object. Normally, however, 3D models are created, edited, and used with one of the many specialist 3D applications. When it comes to outputting on 3D printers, the applications usually don't have inbuilt 3D printer drivers. The 3D model needs to be organized into layers, or sliced to use the standard term. A slicer program works out the hardware-specific commands to make a particular 3D printer construct the 3D model you desire. Finally, in order to employ a router, such as the Xcarve, just knowing the final 3D shape is not enough. You need to also tell the software the steps required to get there. This is done with a CAD package. For this overview, I selected just one application for each activity, picking free-to-use software every time. Of course, in reality, the CAD functionality is much more convoluted than the flow I've shown here, but for simplicity, I just missed that bit out. So here is my overall picture. I hope it will help you when navigating between the types of files that makers need to use.